So today we're going to look at getting 3D city data that includes your building masses, your street networks, your land use, and as well as your topography information so that you can start to incorporate that into your studio projects. We're going to look at getting the data using Blender and kind of using Google Street information to actually download the data. And then we're also going to look at converting it and exporting it into Rhino so that you have perfectly clean geometry and specifically closed polysurfaces so that you can really manipulate and really create clean drawings and have a good base file for your studio projects. So here we go. So we're going to be doing this tutorial in Blender, and this is a free program. It's available on any platform, Windows, Mac, and Linux even, and it's totally great. I think you should definitely download it regardless. And the next thing we want to do is download this add-on called Blender GIS. I have it right here, but I'm just going to quickly go through how to download it. So Blender GIS. So you Google Blender GIS. We're going to go here. This is a GitHub page for it. We'll just go to the code here, and you're just going to click Download Zip. Then you'll have this Blender GIS appear. So we'll just go to Show in Folder. And then you're just going to want to take this zip file. Mind you, it's a zip file, not a regular folder. And you're going to just put it wherever you want. I have it in my Blender file, but you can really go wherever. You can even go in your Documents folder or whatever. And so you have this zip file. The next thing you're going to want to do is go back to Blender. And it's like installing a plugin for Rhino, but it's a bit different. So you're going to go to Edit, Preferences, and then you're going to go to Add-ons, and you're just going to click Install. So that's pretty easy. Go to where you saved it. I did Documents, right? I'll just copy this really quickly because there's actually my UFT OneDrive documents. Oops. As opposed to doing that, I'll just put it on my desktop for now for the sake of this demonstration. And then, so there it is. So I just I just navigated to wherever the zip file was, and you don't have to unzip it or anything like that. You just click Install Add-on right there. I've already installed it, so I'm not going to click it, but it'll be in the exact same place as I am. Then you can go to this little search bar here. This is back in the add-on preferences, and we'll just type Blender GIS. It's right here. And what you see here is you actually have sort of settings for the plugin, and it's just important that you have to specify a cache folder. Just go down to cache folder, click the folder icon, and you can just specify where you want to save it. And it's just important because it'll save the GIS data. So I already have mine, so I'll just accept that. Okay, so now you're good to go. So we'll press A. That's to select everything. And this will be very different than Rhino in a lot of ways, the hotkeys, because it's a VFX program and does VFX standards. So we're going to press A to select everything and press Delete. Kind of gives us a clean workplace. Then we're going to go to GIS here, which should now be available after installing Blender GIS. This little icon should be here, so we're going to click it, and we're going to go to Web Geodata. Once we have Web Geodata selected, we're going to first get a base map, and it's pretty easy. You can leave this all as defaults. The source is Google, but there's other different ways of collecting it as well, but we're pretty good with just Google. And then you're going to get a sort of whole thing of the world, and you can scroll around. Let's say, for instance, a better way to do it is if you press G, you can search for a place. So for instance, I will search for Toronto, and the zoom level just means how zoomed in of Toronto do you want to be. So if I have a zoom level of 1, that's pretty zoomed out. If I type in Toronto and maybe say a zoom level of 16, there we go. So we have Toronto. And maybe I want to just go a bit to the water, for instance. Maybe I'll zoom out a bit. I don't want to grab too much because that'll just take longer for it to all process. So I think this is pretty good. And so yeah, there we go. So now I want to save this area. So what I'm going to do is I'm going to press E, and there you go. All of a sudden export. And it's already like a super high res screenshot if that's something that you want, but we're going to do a bit more as well. So we're going to go back to the GIS tab. We're going to go to the Web Geodata again, and then we're going to type get SRTM. And SRTM is just a file domain by NASA that they've just made publicly available, and it'll give the topography of the boundary that you've selected. It might take a second as it sort of thinks about it, but you can see it's already bulging up a bit in certain areas. In this example, Toronto's kind of flat in this part, not everywhere, but in this part it's kind of flat, but you can see just as I switch between edit mode and object mode, don't worry about what those are right now, but you can see that it's certainly being elevated. Okay, so now we want to place our buildings, right? So we have the topography, which is important to do first, and now we want to do the buildings. Buildings, we're going to go to, same thing, web geodata, get OSM, OpenStreetMap is what that stands for. I typically pick ways as the sort of data type, but these ones as well, haven't played with them too much, but just as an example, there's tons of different information. There's buildings, highways, land use, leisure, natural, railway, waterway. I don't think we need we don't need all of it, but maybe I'll do those 4. And then it's important, we can do land use too and see what that comes up with. It's important is we can click elevation from object, so it will know to base the buildings off of the 3-dimensional topography we just created. And so that's where you're just specifying there. Export Google Sat WM. If you also look at your layers, it's also right there. Building extrusions, so on and so forth. So these are all pretty good as default, and then you can just kind of play around with it. When I click OK, this might take a minute because it is downloading a bunch of data for you. So that's something to be cognizant of. And there we go. So that took about 15 seconds, and now we have a whole bunch of data that's all in its separate layers. So we have looks like highways or that major roads. Yeah, this might be railway. So it's also considering, in this example, this is Toronto, so it's considering like this is the subway line. So there's, it's depending on how you look at it, that's a subterranean railway, but I think it's still valuable to include. And yeah, so here's our little swath of land. We have the water, and this satellite overview is still there. And some things are, obviously the CN Tower isn't perfect, but it's still relatively good, just for amassing, of course. So we're in a pretty good place if we wanted to stay in Blender. But I'm going to show you quickly how to actually get it into Rhino if that's something you want to start working with right away. And so most of these things are pretty good as meshes or curves. For instance, the roads. I'm just going to hide everything else. These are all curves, but the buildings are meshes. And if you don't know the difference between a mesh and a polysurface, a mesh is basically what's used in VFX. Every face, if you see here, if you look at this building here, each one of these is a face. It's a mesh face. And if I were to delete this, you can see inside of it. What's different is a polysurface, if I were to just go back to this example, is actually a continuous, for instance, here's a circular building. This isn't a good example actually. But for instance, if I were to draw a circle, this is a perfect circle that's not made up of separate faces. It itself is just a geometry that is a circle. And that's an important difference for working in Rhino, but it's also an important difference if you're depending on your industry. This is much better for fast rendering, but polysurfaces is really good for having perfect surfaces for fabrication and so forth, and buildability. So we're going to want to take this mesh, which is still good. We're going to take this mesh and make it so we can use it as a polysurface in Rhino. So we're going to press tab, which now puts us into edit mode. So previously we were only able to select this whole thing as a group. Now we're going to be able to select individual items. And what we want is basically we're going to recreate this geometry in Rhino, but we need a base point. So we basically know that more or less so, all the buildings are going to stop at this plane. And it doesn't matter if it's flat or not, because ultimately what we're going to do is we're going to shoot the buildings through. So what the point that we need is the top surface of each one of these buildings. So we're going to go into it, we're going to select one of the faces, and then we want to select similar. And the way we can select similar is by pressing Shift-G. And what the normal means is every face, every mesh face that's pointing in the same direction, which means this mesh face is pointing upwards, if you were to imagine an arrow, invisible arrow sticking through. So we're going to press Shift-G, click the normal, and there you go. So now we can press Control-I to invert, delete, and then click faces, and we have all those. And better yet, we don't even need the actual mesh face there. So we're going to select all those now, click faces, and then click only faces. And there we have it, just another layer of curves. So now that that's done, we have all of our geometry that's pretty much ready. And this plane is almost always fine for it to be a mesh geometry, just because that's kind of the best way to work with sort of a landscape, is for it to be a mesh in a lot of instances. So the first thing we're going to export is just the buildings and the surface. So file, export, OBJ. We can go to desktop. We can type Toronto, and then quickly I'm just going to do over here some settings. Selection only. Mind you, OBJ is also the correct file format for 3D printing, just as a heads up. For transformation, we actually have to just correct something. So for forward, meaning like forward in the document, it's just like Rhino, Y is forward, and then Z is up. They're the same. So that's good. And then we're just going to press export OBJ. And just like that, it's all done. So we have it on our desktop now. So you have two items on your desktop. You have Toronto and Toronto. And the one you want to open, if you go to your properties, it's the OBJ. The other one is an MTL file. And ignore this part that says Photoshop. That's not correct. But MTL is the texture associated with the OBJ. Okay. And then we'll do another one. File, export, OBJ. And we'll call this Toronto Roads. And we just want to be able to differentiate between them while we bring them into our new file. So you see I just dragged it into this brand new Rhino document. I'm going to click Open File this time just to make things a bit easier. So now that we have our geometry imported, there's one thing that you really want to do, and that's confirm the scale. So what I realize is when I open the document, my Rhino document's in millimeters, and I know that Blender always works in meters unless you change it. So my guess is that our scale is actually off by 1,000. And so if I just go and check the length here, and you can just check the length down here. So we're at about 4,280 millimeters. So it's about 4 meters. So that's probably not right, is my guess. So what we're going to do is we're going to take units. And then we're going to go to model units, and we're going to switch it to meters. We're going to press OK. And when it says, do you want to scale it? You're going to click no, because that's going to make it so none of the geometry scales with the unit change. So now when we check, we're going to have a document size of 4,280 meters. And we can just go back to Blender and quickly check that. We can select the measure tool and quickly just go here, for instance, 4,287. So that's right. It needs to be in meters. And that's something that you need to do before you start working on your project. And you can already see if you go to it, like you have this map already. So you already have a high definition screenshot, which is pretty handy. So I'm just going to click cell curve. I'm going to group these curves. Why not? And I'm also going to put them onto their building layer. Change object layer. And then the roads can come in now, and I'm going to import them. Not insert them, but import them. And that should kind of keep the same origin. Yeah, so there you go. Importing it keeps the same origin point as the other stuff that you had imported from. So it's aligned perfectly. And we can sell those curves now. And we'll put that onto roads. And change object layer. There you go. Bada bing, bada boom. So now we have these buildings. And while we could have just imported the mesh, which is totally fine, what we're going to try and do now is just a very teeny bit of Grasshopper to essentially extrude these all down to the same plane. Don't be afraid. You could technically just hold it with the gumball and hold control, but I think we're going to be a bit more precise than that. So we're going to open up Grasshopper. Dun dun dun. And just follow along with me. Fortunately, because it is a Grasshopper script, you can just reuse this 100 times without having to change anything. If you have never used Grasshopper before, that's also okay. I'll take you through it step by step. So we're going to type ungroup. We're going to select all the curves right now, and the first thing actually we want to do is just join them all. This might take a minute, so bear with me. Okay, and there we go. There we have it. So they're all closed curves, and that's what we want, is we want closed curves, because it'll just make sure our geometry is super clean. One other thing before we keep going is I'm just going to type sell bad objects, just to make sure that no bad geometry came into the file. And now we're going to start in Grasshopper. And what we want to do in Grasshopper is essentially, I'm gonna bring this in as well. So what we're going to use Grasshopper for is take all these curves of various heights and extrude them all down to the same plane. And we're going to extrude it just past this landscape plane. So they're all connected to the ground. So what you're going to do is you're going to press spacebar. Whoops. I'm going to select curve again. We're going to double click onto here, and we're going to type geometry. I'm going to select this geometry icon, and then you're going to right click and set multiple. So you're going to right click the icon and say set multiple geometries while all your curves are selected. Make sure all your curves are selected before you do this. And now all of your curves are in in your Grasshopper document. Just like that. And now, so this is a couple steps, but I think you'll be okay. What we want to first do is we want to know how far to extrude these from. So we need a point A from each curve and then a point B. So we're going to first get we're going to type area, and I'll explain to you in just a sec. This is the area component, and the area will give us the center point of each surface, just like that. And that's valuable because now we know how far that point has to travel to get down to the base plane. And we also have to import our base plane. So we're going to set that geometry, same way as we just set the curves, set one geometry, create a bounding box around it. You know what? This will be much easier for you to not have to follow along with that part. So what I'm going to do is I'm going to create a bounding box in Rhino. I'm just going to type bounding box, press enter, and then explode it. And I'm just going to take that bottom plane, and I'm going to delete this now. So what this bottom plane is it's the absolute lowest point of that geometry. If you zoom in super close, you can see that it's just below the rest of the geometry, and that's super important. So now we're going to load this one in. And then we're going to get the area of that one too. And what you'll see, it's kind of glitchy right now, but what you'll see, so I move this over. So I hid all the geometry except for the ones I had selected. So there's all the original curves, and there are the center points for it. And then if I disable that, here's that one center point of that surface here, just like that. And now we just want to pull all these points to that surface. So pull, point. Oh, beautiful. So we actually don't even need this one. So we're going to take the centroid point, and we're going to have that as the points that we're pulling. And we're going to use the base geometry here as the geometry we're going to pull it to. So you see they were previously all up in the air, and now they've been extruded down. What this gives us is the distance, and that's all we need to know how far we want to extrude these things. So we're going to type extrude now, because that's the command we want. And then in terms of the distance, you have to specify both the amount but also the direction. So we're just going to type Z and select unit Z. And then you'll plug in unit Z into the direction, and then you're going to actually, since you want it to go down, right? Because it's just calculating if you look here at these numbers, it's calculating a positive value, but we want to go downwards, so we want to calculate a negative value. So we're going to type negative, plug that into there, and then we're going to plug that into there. And I'm just going to open up what's called a panel real quick to show you exactly what's happening. So there's a bunch of different numbers, but all you need to understand is that this is the distance that one of those curves will have to extrude for it to touch the ground. And so that's what's being plugged into here. All we have to do now is take our original curves, and there we have it. We'll wait just a second. And we check it, and we'll just deselect to confirm. Yeah, amazing. So there you go, there's your first Grasshopper script. We'll call this For the meantime, we'll call this, not gildings, that would be preposterous. Gildings, polysurface, for instance. And I'll let you decide how you want to name them. But now we're going to just, what's called baking it into the Rhino file. Because right now, this is all not selectable. So what you're going to do is you're going to go over to the one, the extrude. You're going to press the middle mouse button, and you're going to press bake. What bake does is it brings into the Rhino document. So you can see that the one last thing we have left to do is all of these are hollow. It's actually kind of cool. But what we're going to type is cap, because all these are flat instances. So we can type cap, and it will make all of the objects closed for us. There we go. Bada bing, bada boom. And the reason why this is valuable is because all this geometry now is super clean. You see that your edges show actual edges here, whereas prior a mesh wouldn't be able to show an edge like that. I'll bring in the mesh just to compare with you what it would look like. Just to compare the difference between the mesh buildings and the polysurface buildings, I'm going to quickly show you. So what we're looking at right now are the mesh buildings. And if we were to, first of all, if we're selecting this as a mesh, you see it's actually all being selected as one mesh still. You can correct this by just typing disjoint, split disjoint mesh. That will separate all the disjoint meshes into their own separate components. But if we were to go into like a line mode, for instance, what you will see, for instance, if we compare this mesh to our polysurfaced mesh, what you'll notice is there's no curvature, there's no outlines, because meshes operate a bit differently. And that's not to say this is a bad thing, because in a lot of cases meshes are faster to work with. You can still make 2D meshes too. Just as an example, but they're far less likely to be clean once you mesh them. Fortunately, the Blender algorithm is good, and it's pretty good. But in most cases, you want to work with polysurfaces in Rhino. And what's also great is you still have those initial curves. You still have those initial top surface building curves profiles, so you can do whatever you want with them. For instance, if we want to hatch, create a hatch for a plan, right? You can type hatch. What we'll do instead, this might also be better as a Grasshopper procedure, but that would also be a very easy one. So we're gonna select all these. I'm just gonna make them black. I don't know why they're not black. And let's see what we can do here. This is one last thing we can do. So we're gonna type hatch, create hatch, and you just have to create a button. It's just called button, and you're just gonna plug that into the bake, and then you're just gonna again get your geometry, select multiple geometries, and put that into the curve. And I'm going to press this button, and then after a second, there we go, we have the hatch. So now, if we were to go into plan, some of these buildings did turn out to be, oh no, so I'll still the hatch. And because it's intersecting with the original geometry, it's kind of causing an interference. So we're just going to lift it up by 1 millimeter, and that should kind of take care of it. So there's your figured ground. And just like that, you have a perfectly clean file that you made of whatever set you want in the world, and with frankly any extent you want in the world. I'll show you an example of something with a bit more topography. So just another example that gets a lot more topography in it as opposed to buildings. I've chosen the Grand Canyon, and I'm just going to quickly show you what happens when I get the SRTM data from NASA. So there you go. It's pretty highly detailed. It's pretty great. Another example of a topography might be Riverdale Park. Here we are again. I've just quickly searched up Riverdale Park. I'm going to press E again, just like we did before. And we have the highest quality screenshot. We're going to type GIS. And we're going to get the SRTM again and see what happens. And let's see what sort of resolution we get for Riverdale Park. So there you go. You can see. And while it's not as extreme as the Rocky Mountains, you can totally understand the topography that's happening there if you compare the two, just as you switch between the two modes. And again, if you want to get the data, so if we want to get some building data, we'll do the same thing. We'll go to web, get OSM. Here's all our information. The default height, in case these buildings don't have a recorded height, we can shift it. 20 meters is probably a bit too high for a residential neighborhood. I would say maybe 30 feet would be good. So that's let's just say about 10 meters. And let's see what happens. And there you have it. Everything all set, ready to go. Anyway, I'll leave the Grasshopper definitions available online too. And thank you very much for listening.